Hello, hello. This is Brian yet again for Tavarin Games with another update on Littlevale. So, over the last few weeks, I managed to build a skill system and its progression into the game that will change item quality based on your skills and those particular things. I rewrote the NPC Pathfinding based on a tutorial by CodeMonkey, which I will link to in the description below. And finally, I got dogs added to the game, at least a couple different breed of dogs. So let's get to it. So the first thing I want to talk about is, as mentioned, the skill system of the game. So I added in these lists into the player controller script, the skills themselves, as well as the maximum value that skill can have. And those are both just integers. And then in the start, we add in the skills themselves. So right now, I've added in the farming skill, fishing, cooking, your animal care skill, and I just want a fifth one for the UI I added. So I've added in the mining skill, which isn't applied to the game yet since I haven't written in mining, but that is a future update I plan on adding in. So those are set and they have their maximum values. So the way those actually work is whenever you pick up an item, so when you say pick up a crop, if we go up, I don't know where that is, we actually call this calc quality function. So this calculates the quality of the item that you're going to receive based on your input skill level, as well as this other integer I put in called the care level. Now the care level right now applies to cooking, where the care level is the quality of the ingredients actually being used in the recipe. Otherwise though, for farming and fishing, it just takes into account the skill level right now. So when this calculation or this function is called, it actually increases your skill level by 1 in that particular skill. And then it sets the default quality to 1. The quality of an item is an integer that's either 1, 2, 3, or 4. And that multiplies the value of the item by that amount. So a quality 4 item is 4 times as valuable as a quality 1 item. So then it figures out how much we need to add to it. So it checks first, is there a care value being input? If so, it takes 1.5 times, so the maximum you can add to this one is 3. So 1.5 of that is going to be a random value multiplied by your current skill and then divided by your skill max. So if your current skill is 500 out of 500, it'll be a random value that is between 0 and 1, basically. That is then multiplied by 1.5. If your skill's only, say, 100 out of 500, then it'll be a random value between 1 and 0 and 0.2. That's multiplied by 1.5. So the higher your skill value ends up being, the higher the quality addition ends up being able to be. Now it still has this random value with no floor. So you can still get a quality 1 item when you're a high skill level, but the odds of you getting a higher quality item increase as your skill increases. And then if there's the care value, it is also then multiplied. It's out of 100. Multiplied by random value, that's the other half. If there isn't a care input, then all 3 of the potentially added on skill or added on quality points come straight from your skills. So then it just puts those together and then it rounds them off to make sure that it's an integer so that the function can work. And then it checks, is it greater than 4? Now this should not give you anything greater than 4, but just in case it does, I round it off. If it's greater than 4, I just make it 4. Right now I'm printing the quality just to the debug log so I can check the values, and then we're just returning that in the into the item transfer script, the transfer item, which then puts it into your backpack with the quality intact of the item, which we talked about in a previous update. So if we want to see that in action, let's just start the game. It always takes a little second to get going. Come on, let's go. There we go. Oh, we're zoomed in a bit. Let's scale this back. So just quickly end this conversation. So I actually have a game loaded for the farm skill test. Now, over here, let's just get rid of that. We select the player. Down here, you can see the current skill values and the maximum skill values. So our current skill in farming, which is 0, is 0. So let's just grab a few crops. Pick some up. So you can see down here, all of those are adding as quality 1. We'll just check that in the inventory in a second. We'll just grab this entire row. Just so you can see we get a bunch of different objects. Again, they're still all quality 1. So if we look at our backpack, we got 25 carrots, all base quality. regular when our skill 0. And our skill increased by 25 because we picked up 25 carrots. So, but let's say our skill is actually fully maxed out. It is already 500. So let's grab those, and you can see we're getting higher quality items. So there's 4, 3, 2 is popping up. Oh, some of our NPCs are pathing, and we'll talk about that momentarily. So let's grab up a bunch of items, get this row, a little. Now the sound design in the game isn't great yet. I still haven't decided what I want the soundscape to be like. But anyway, we only got 3 new carrots of quality 1. We actually got 8 quality 2 carrots, a quality 3, and then quality 4 and 13 quality 3 carrots. So you can also see in the value that the value is based on the quality. So that's been input to the game. It's also been added to fishing. So the higher your fishing skill, the higher the quality of fish you catch. So that will allow me to have sort of the more role-playing game aspects, possibly putting in items you can use in order to increase your skills and things like that. So that is now in the game. So we now have that RPG mechanic. Oh, I should open the game up. Back into the game because I also made the UI for that. So we're going to get talked to again. So right now that's tied to the L key. So you can see I haven't made the art for the actual skill icons yet. I've just put the words in for what they are. But you can see these bars, and now because our skills are 0, all these bars are empty. So let's close that. Let us say make this say 300. You have 4. You fished a lot, so that's 400. 75 in there, 80 in there, and like 200 there. So if we press that again, you can see there we go. The UI is responsive, so you can see our skill levels have now increased in each of those. So this will let you keep track of your skill progress. And then as I add games, I plan on adding other things to the game, like maybe painting and making artwork. And I'm not really sure what else, but sort of because it's a list base, I can just add these on as I think of skills and apply them to the game quite easily based on that quality calculation script. So there we are. That is the skills in the game. So the next major update was the pathfinding. Now, so I have the actual scripts open here. 3 new scripts for that. The old pathfinding, which did work, but it was a bit slow. So if I open that up, the code for that, the way I was doing it before is every time NPC or an animal needed to use this pathfinding script, they would clear out all their pathfinding information, and then they would start basically drawing out tiles using this tiles and distance function. And what this does is it currently checks the tile that it's taking in, it grabs the neighboring tiles, and then it calculates the distance that this current tile is to the destination, and then there's some debugging thing. And then this here is checking, is that tile walkable at the moment? Is there anything in the way? If not, then that tile is approved. Its neighboring tiles are approved, and it then goes to the next tiles in the distance. Now this function works quite well for shorter distances. If you're going like 30, maybe up to maybe 50 tiles, it draws out a grid of all the distances. And then it was back checking that grid using a ray tracing to find what is the furthest tile away from the destination that it can currently see. Once it figures out what that is based on sending out a raycast line from that tile to each one. Once it determines, okay, this is the smallest one it can see, it then sets that one as a path node and then goes to that tile and continues this until it gets back to the destination. So again, this old pathfinding script did work. It was one I wrote when I was first making this game and just trying to figure out how do I pathfind. And I didn't look up any tutorials. I just went and reasoned through what is a way I can write a script to do this. But as I stated, it's pretty inefficient. So I was using like subnodes that the NPCs and animals could use. The path was too far, like the destination was too far away. It would go to one of these subnodes first, between the NPC and the destination. And then potentially go through multiple subnodes until it could finally have a short enough path that it could calculate to the destination without lagging up the game. But this script, yeah, it was short. Or sorry, it was quite slow and it was inefficient. It would lagged the game quite often. So I looked up pathfinding scripts. I knew about A-star pathfinding, but I didn't know how it worked. So I looked up this tutorial by CodeMonkey, which is a Unity tutorial for how to write a pathfinding script using the A-star pathfinding algorithm. Now, the way he does it works quite well, but he's using a very complicated grid object system that he developed in another video, which I didn't really need for this game. I didn't need all of that. So I decided I would code up my own grid system. So this path object script, this is the actual grid itself. So it takes a multivariable array, so it can set an X and a Y. I actually didn't even know I could do this before the tutorial, so this is something new I learned, and makes this grid. I also have an offset, which is basically how off-center the grid starts. So it means that my game world doesn't have to have one corner at 0, 0. The game world can, right now the center of the game world is on your farm. So this offset allows me to then have the grid extend to the bottom left of the farm instead of having the NPCs unable to path in that direction. And we set the width and height. And then this draw grid function is called when the game first starts, and it's called once when the game starts. And what it does is it goes through the width and the height from the offset. It checks or it makes a new path node object. So the path node is, again, something that I got from that tutorial. Instead of just having a vector of the coordinates of the path node, this object actually allows me to store the X and Y location of the node, but also store in this pathfinding information that is used by the pathfinding script. So the G cost, H cost, and F cost, and that is basically distance to the destination, distance it takes to walk from the current location to that tile, and then those two added together. And the way the pathfinding function works is it tries to find the tile that minimizes both distances. So the distance from the player to walk into that location, and then the distance from that tile to the destination. We also note whether or not that tile is open to walk into, so is walkable. I just used open as the variable name. And now I did something a little bit different than him. So he was just using true and false for whether the tile was walkable. But that meant you couldn't have a tile that was only walkable by certain NPCs. What I wanted to do, though, was have it for, like, your livestock animals aren't able to walk through doors or fences and that. They can only go into and out of barn doors. So they have there's a specific barn door object in the game that is meant to be passable by livestock. So you can have your barn and they can get in and out to their bed and out to the food. But for NPCs, I want them to be able to walk through all the doors in the town and potentially doors on your property, any doors they want. So instead of setting true or false, I have the open and close values as integers. And then an open integer of 0 means it's just a blank tile. It's just the ground, it can be walked on. And then meanwhile, if it's a barn door, it gets a value of 1. And if it's any other type of door, it gets a value of 2. And then I just set impassable tiles to a variable to an integer of 10. So this is so that I have some options, so that I can really fine tune this and I can use different values for different passable objects in the game of how they can be passed. And then we use this old open value is so that as NPCs and animals walk across a tile, they're going to block it when they're on that tile. And I don't want the pathfinding script to try to path through an NPC or an animal or the player and think, oh, this tile should be passable, and it's not, and the pathfinding script tries to walk through it, and it just gets all confused. So I needed a way for the tile to be able to be switched on and off back to its original integer value. When it's true false, you don't need this, because if it's currently passable, it's just true. Otherwise, you set it to false. Doesn't matter. But because we have these different integer values, 1, 2, and 10, we need to store what the original value is so that we can reset it. Now, the other thing I found is when this grid was first drawn, anything it found in the way using just a little ray trace into that tile would permanently block it off as a 10, no matter what. But let's say that was an NPC, an animal, a pet, the player, whatever, something that can move. I needed it so that it was only marked as a 10 while it was there and wasn't permanently 10. So I need to set that this old open value, this one that's sort of the original thing, sets to 0 if the object is a player, animal, pet, or NPC. If it's not, then it becomes this higher value for the doors or walls, but if it is one of these movable things, it just stays at 0. So this update script is just a debugging thing to show the actual grid and how it's being drawn so that I'll be able to show it to you guys. This will be deleted eventually, so don't worry about this. And then we have a function, this update node function. So this is called anytime something moves. So any of the movable things, so the animals, NPCs, players, all that, when they walk into a tile, it sets that tile value to 10 to block it off from the pathfinding script. But then when they move out of the tile, it can then set it to whatever the original value was, that 0, that 1, or 2. And then there's just a little script that will return what the actual node is at that location from the array. So we go to the array and we take the x value input and then subtract the offset, and the y value subtracting the offset. So that means that, so basically a tile that's, say, at location, the actual location 0, 0 in the game, in the grid that's going to actually be location 80, 25. So this just subtracts that offset out so that it gets the right tile. So if we want to look at that grid, let's go to the game. So we'll play it again. It'll take a second. And then let's just pause that so he stops moving. So if we go back to scene view, there we are. So all of these lines are the grid. So this is the total size of the grid. The ones marked green are passable tiles. The ones marked red are permanently block tiles. So you cannot walk through those ones. So actually we have a spot here that cannot be gotten to. Let's see what that is real quick, because I'm not even sure what that is. Yeah, so we can't get to the tile because the chair is blocking it. Let's put that roof back. And then doors, though, are marked, if we look here, so we have a blue line across doors that are only passable by NPCs, and then a yellow line goes across these doors that are passable by like your livestock animals as well. Your pets can cross anything. And then I have these black lines actually run when the pathfinding script runs to show tiles that were evaluated by that NPC, because I wanted to see sort of which tiles are being done. And this is the simplest way to display it without trying to put text or numbers on the screen and creating mesh objects to do that. So you can see, though, we have the full grid that can then be referenced. So if we go into the script, we have one pathfinding script. So originally, my old pathfinding script, every single thing that could move had this pathfinding script attached to it. Whereas in the case of this, I've actually just attached to the clock script, which everything already uses because it has to check what time it is for behavior checks. And it now has the path object script that generates the grid, and this pathfinding A script, so the A for A star, that is actually doing the pathfinding. So how does that actually work? Well, it grabs the grid that was generated by the clock, this path object grid, which is generated over here. So this is generated once, and then this pathfinding A script can grab that grid. And that grid is set and unchanging. Well, I say unchanging. It changes whenever something walks into a tile, and that update tile function is fired. But what it does when it's getting the path is it's actually returning a list of locations, vector2 locations, that is going to be the path the NPC can take. Now, fortunately, that's the exact same return list that my old pathfinding script used. So in order to integrate this, all I had to do was just tell it to look at pathfinding A instead of pathfinding. It made it much easier to integrate this script into the NPCs and the animals and all of that. So the first thing it does is it checks and makes sure are the start node and end node within the grid. Otherwise, there's no path, and it just doesn't try. We then have this open nodes, which is the nodes it has to evaluate, and the closed nodes, which is the nodes it's already evaluated. And then it goes through the whole grid and just sets the distance into the or the distance traveling in the tile for the tile to get to the destination to a really high value, so that where all the tiles end up with these very high values, and it knows it needs to recalculate through. So that actually is very efficient. It runs very quickly. Even though there's tens of thousands of nodes, this script takes milliseconds to run. So the first thing we do, we grab the start node that was passed into the script from the starting position, and we calculate from that node, we grab the node initially using the get node, and we grab the end node. And then we set the g-cost. So the g-cost is the amount of distance it takes for the NPC to get into that tile. So in this case, that's just 0 because it's your starting tile. You're already there. And then it calculates the distance from that tile in a straight line to the ending node and sets that as h-cost. And then it just multiplies or adds those together to get the f-cost, which is just a function in the path node. Literally just add them together. So that's added to the open nodes, the ones it has to evaluate. So it evaluates that node, and what it does is, so it checks in this list what is the lowest current f-cost value using a function, get lowest f, to figure out which of the nodes that it has to evaluate is the lowest f, which is the node that is the most likely to be the best one to path into, because it is the closest to the destination and to the NPC or whatever's pathing. So pretty simple script there. And again, the CodeMonkey tutorial will go through all of this in much greater detail. But what it does is it grabs the neighboring nodes to that one. So the get neighbor function. Now in the CodeMonkey tutorial, he has the NPCs able to path on angles as well. So it can grab all 8 nodes around the current tile. In my game though, I wanted all the movement to be linear, vertical, horizontal. So it only grabs the nodes above and below and to the sides. And it checks, okay, is that actually a passable tile? And like, is its it's pass, or no, it doesn't check that, sorry, it just returns those nodes. Up here, we then look at those in the open nodes, and we check, is that node higher than the allowed door type? So if, like, an NPC will be allowed to go through doors up to integer 2. So if it's higher than that, then it knows that this is an impassable tile. It puts it in the closed nodes and just leaves its F value as this, or its G value as this hugely high value. So it knows, okay, that's not a tile we want to look at. That one can't be passed into. Otherwise, though, it calculates the G cost into that node. So we calculate the distance as another function, which takes, which basically is adding 10, or it's taking the distance to walk into that object based on where you are. In this one, basically it's adding 10, or actually in this case it's adding 1. Sorry, 10 was from his tutorial. And then if the new G cost is lower than neighboring one, which when it first evaluates a tile will be this. Otherwise, though, if that's a tile that's already been evaluated, it's only checking, is it easier to get to this tile from somewhere else? And then it calculates the new H cost, which is the distance neighbor, calculates the F cost, and then it saves that in the node. It is also checking, if it's the end node up here, which means it's actually found the path. So it's going through all these open nodes, calculating out these F costs, finding the lowest value, saying, okay, that's most likely the one we need to look at the neighbors, and it's just repeating that until it manages to find the end. At which point, it then will calculate the path, another function here, at the bottom, which will go through those evaluated nodes, and it's going to go backwards through that, and it's just looking, is this the lowest value you can get from this current node, and it just draws its way all the way back. And boom, you end up with a pathfinding script that works quite well. So you can see, like NPC, so Derek here has drawn a path to his work, which is in here. So you can see he evaluated into the backyard a bit, and turns out that has barriers. So that got evaluated, and up this sidewalk a bit, but that's not the best way. So you can see the path mostly, though, evaluated back here. Whereas with my pathfinding script, he would have had to evaluate every single tile within a box around it that's the same, that's basically the distance to the destination. So this is a lot more efficient. So if we unpause the game, we're back in, he's going to talk to us. We go to the scene, you can see Derek here is following that path he drew. Brad over here, you can see his little speaker there, which generates noise for him. The game does get a bit laggy in the scene view with all this debugging stuff on, so that's why he's just hiccuping a little bit. But that's working quite well. So one thing we can do, if we want to see a longer path, let's pause the game and go to the clock. Maurice likes to leave the farm at around 1 p.m., so I think that's what, around 7:40. Let's see what time that is. So that's 12:20. We're not quite there. Let's set him to 7:70, so he has a few seconds to do that. So we'll go into scene view, and right before 1 o'clock, he paths. So there he did it. So let's pause that. So he is looking for all the way up here in his office. He wants to sit in his chair, which is up here in his office, and you see he managed to get path all the way up. And then most of the tiles he evaluated were correct and were pretty much in the right direction. But the thing is, with this, he only had to he looked a little at the farm, but for the most part, he pathed the right way. Whereas my script would have had to evaluate a big box like this all the way around and check all those tiles, and that would have been too slow. He wouldn't have actually been able to path that. But you saw on this, he was able to path quite efficiently, and he's on his way. Again, in scene view with the pathfinding debug stuff up, it does cause the scene view to lag a bit. If I just walk around in the game, though, it's without that debug stuff visible, it's working just fine. So hello, there's Marie pathing. And we can follow him up. Now, the player walks faster than the NPCs, so we can catch up to him. But there he goes. So that new pathfinding script was very important to getting this game to run efficiently, because I was getting a lot of lagging time with the old script. So that is done, and that's a big part of the game. Now, the final thing I did, as I mentioned, was I finally added dogs to the game, as promised in my first look video. So let's look at their sprite art. So the first one I did is my favorite breed of dogs, the Shiba Inus. So here's his little sprite cheat, or hers, your choice. Looking, I have to say, very adorable. I think I outdid myself on the cuteness of this sprite sheet. I also then decided to add in Huskies as the second breed, since a lot of the features, like more of a curled tail and that, would be pretty similar. And I was able to pretty easily just take this sheet, make a few modifications, change the color scheme, and make our little Husky. And actually from the Husky, I could add in the Alaskan Klekai, since they are basically just miniature Huskies. So if we go into, into the game, so those guys are in the resources of the objects folder. So you see with cats from before, and then we have our dogs down under D. So here are our new dogs and the icons for them in the store. So let's just pull a dog into the game, a little Shiba Inu. Let's set their coordinates nicely. So and let's pull a Husky into the game because he's so cute. And then let's set them on the farm as well, because the animals won't actually path above, or your pet animals won't path above this line in order to keep them on the farm. That way they don't actually wander off into the middle of town and then end up just somewhere else in the game. They are going to stick around on your farm property. Now the actual code for the dog, which actually we have to go over here, I guess. Oh, we haven't opened it. So the dog controller is just literally copied and pasted the cat controlling script at the moment. Since these scripts are still quite simple of the various behaviors they do, all they can do, like they will look for food when they're hungry. If they're not hungry and it's daytime, they might wander around, or they'll just idle in place, they'll just stand there. And then at night, they look for a bed. That's the only behaviors I've coded in. So the dog script is using the same exact script as the cat right now. But by having it a separate script, I'm going to be able to make them each more unique. And at some point, I do plan on making a general animal script, since these scripts are all very similar, where I can also slim down this code, because as I wrote this, I was just like copying and pasting code. And it's generally a mess. I need to go through and thin it down, set up some specific functions, like for movement, just have, here's one function that deals with movement, instead of having movement being dealt with here, as well as in other locations here, and that, like, the movement is dealt with here, like tons of different places, the same code is running. Oh, you can also see in here, this is an update to update when a cat finishes walking into a tile, it makes that tile impassable. So this type of code is on every one of the animal controller scripts, the NPC scripts, and the player script. Whenever they move, that's what's updating the pathfinding. But yeah, so we have the animals in the game. So if we start the game, now they wake up at 9 a.m. and the game starts at 8 a.m. So they're going to immediately try to go to bed. Let's finish talking. So look at that. They're walking to beds. So the Husky finds the bed first. Shiba Inu can't sleep there, so he just pops on the animal bed. And look at how cute they sleep. Oh, so actually we can join the Husky in bed. Oh, that's so cute. So the Husky's awake. Let's give the Husky a little pet. So yeah, we have dogs in the game. Let's actually head into town. So those are purchased at the vets. So they are objects in the game. Animals in the game that can be purchased if we run across town. The vets is a little ways away because it's not the most important shop. I wanted the seeds and the building shop that you're going to need to go to more often closer to your house. But if we go here, we have the Shiba Inu, the Husky, and then the Klekai. So the Klekai, actually, let's purchase one of those. Oh, whoopsie daisy, wrong key. We have to press Q first and then E to purchase. And we should have a nice little Klekai popping up on our farm. You can see in my console down here all this debugging stuff for the pathfinding script. That will be deleted from the final game. Oh yes, down and run is that. Look at our little Klekai. So literally it's the exact same as the Husky. I just made the sprite smaller. And done. I could get a third dog species in without having to make any new sprite art. And look how cute he is. Oh my god. So yeah, that is my update for the last 2 weeks. I'm going to keep working on the animal script and adding things to the game. But once again, the CodeMonkey tutorial I use for pathfinding will be linked to in the description. So check that out and give him your support. And as always, if you made it this far, thank you for watching, and feel free to support me on Patreon if you like the look of this game and want to help its development.